Hello viewers, I Dr. Prashant Badgujar, lecturer in electronics, Government Polytechnic Ahmednagar, will be telling you about fundamentals of the PLC. So, the learning objectives of this session are: after this lecture, the students will be able to understand need of PLC over the electromechanical relay. We will be able to describe the function of PLC internal blocks. We will be able to identify the type of PLC among its category of classification. And finally, we will be able to state various advantages, disadvantages, and applications of the PLC. So let's begin with the session. So you might have seen the conventional relays which you are using in various circuits, that is used for isolation or any kind of other purpose. But these relays have certain limitations. These relays are not automatically uh, suitable for automatic control. Those are very bulky, and if we are using this in very large number, then the complexity of network gets increased. So there are various disadvantages of these electromechanical relays. So we will see why we are using these electromechanical relay. We are avoiding these electromechanical relays over the PLC. PLC also consists of the relays, but those are solid state relays. So we are going to see the need of the PLC. So this is our conventional relay which we are using. These are the primary windings to which we give a supply from the one side. If the current will flow from this coil, it will get energized and it will uh, connect supply from NC to NO. So this is one terminal normally closed, NC. This is normally opened, and this is the common terminal. So we will connect the line to this line, or the red wire to this supply, and we will get this voltage at this point, because it is a normally closed. Whenever signal is not applied, the signal will be available over here. But if certain supply is connected to primary winding, it will energize this uh, internal mechanism, and this NC contact will there is a pointer, and this will disconnect from this connection, and it will be connected over here. So this will become normally closed from normally open, and this will go offline. So it will be connected to normally, it will be treated as normally open, not normally closed. Okay, so likewise we are going to do the connections. So hardwired panels are very time consuming to wire, debug, and change. So we will be as I have told you, these relays are very complicated to make connection, and it is a time consuming to wire, debug, and change particular connection. Also the require our means sophisticated, or the industrial system require uh, certain kind of things. Those are highlighted over here. The requirement of computer controllers to replace hardwired panels are, so these are the requirements: solid state, not mechanical. So relay should be the solid state, not the mechanical. It is easy to modify IO devices, so we can easily connect input and output to these kind of relays, which is not possible, or which is time consuming in case of these mechanical relays. These relays can be easily programmed, so there should not be the bulky connections or uh, complicated interface. So we can easily program, or we can easily connect one input to the another line likewise. So it should be easily programmed, and those should be maintained and able to function in the industrial environment. Okay, so in not all cases these relays are useful in the industrial environment. Okay, so just to achieve these benefits, we are using a PLC relays. So which are the advantages of these PLC relays? It has a high switching speed. There is no contact debounce. What happened in these relays, whenever we connect a supply to this primary winding, NC become NO, and there is a like pointer get deflected, there is a debounce, so it will again go here, go there, go here, go there. Okay, so there is a debounce like a key which happen in the keyboard, but this debounce is not observed in the PLC relays. Okay, so there is a little switching noise, no contact in arcing, low power is required to energize PLC relay. However, here the power requirement could be more. Okay, and it is highly reliable and it has infinite life. That's why these PLC relays has certain advantages over these mechanical relays. So, how this PLC and relay look like? We have seen these these relays. So, PLC look like this. So, these are the various configuration or the various PLC by the various manufacturers. So, this is the PLC manufactured by Siemens company. So, these are output and these are the inputs. Okay. So, where are these solid state relays? So, these are the contacts of those solid state relays. Okay. So, we will connect input or output to these relays. So this will act as a these NC and NO terminal, and we can connect supply over here. Okay, and primary windings are means that is connected to that is connection is somewhere over here. You just remember that in this input and output cards, these PLCs are internally connected. So we are going to see how these relays are there whenever we will see the input and output modules. Okay, so just remember like this the PLC relay look like. Okay, so this is the fixed configuration of PLC which we cannot expand, and this is the modular configuration of PLC which we can expand by it means we can add inputs or outputs to these PLCs. Okay, so if you open this cap, then there is arrangement of these relays in this input output cards. So this is what it looks like. Now we'll see the difference in PLC relay and the electromechanical relay. So as I have told you, PLC relays are a solid state computerized controller, whereas our relay general purpose relays are a electromechanical device. Relays perform only controlling activity, while PLC relay perform monitoring as well as the controlling activity. So this is the advantage to us. Programming of this relay is possible. PLC relay is possible. However, we cannot program the electromechanical relay. For this, you have to manually do the connection. So complexity of the connection will get increased. Okay. So as programming is possible, this PLC relays has a digital system, and these electromechanical relays are generally preferred for the analog system. PLC relays can be controlled with the help of functions, timer, counter, memory. These functions are not available in electromechanical relay. It gives only one function, that is a fault detection function. Okay, and then design of PLC relay is easy. We can easily modify the design circuit. The relay based circuits, electromechanical relay based circuits are difficult. We can expand input output of the PLC. We cannot expand the electromechanical relays after certain limit as after certain number of inputs, as it has a limitation. PLC provide more expandability. relays provide less flexibility. You can easily find the fault by using software, but finding of this fault is very hard in case of the relay, as we have to manually check all the system. PLC has a time response nearly about 50 millisecond. Relays has a less than 10 millisecond time response. In PLC relays, the memory is available. On the relays, there is no memory available. So this is the disadvantage of this relay. PLC can be of two types: compact and modular PLC, which we can expand. Uh, Relays has a three type: electromechanical relay, thermal relay, and the induction relay. Size of PLC relay is less. Size of electromechanical is large. So circuit becomes very bulky. We can set passwords to the PLCs. Relays does not have any kind of password. If the PLC relay will get burned or it needs some maintenance, then for lesser time we should keep uh, in lesser time we can just do the maintenance of the PLC relay. However, in electromechanical relay, the time required is more. So, okay, so downtime is less here, and it is more in the case of relays. PLC relays are more reliable, while electromechanical relays are the less reliable. Okay, so there are many advantages of PLC relays. So that's why now the electromechanical relays are hardly used in the automation. So PLCs are preferred over the electromechanical relay. Okay, so what is the PLC? The definition by National Electrical Manufacturer Association is: it is a digitally operating electronic apparatus which uses a programmable memory for internal storage of instruction by implementing specific functions such as logic, sequencing, timing, counting, arithmetic to control through various digital analog input output module, various type of machine or the processor. Okay, so the definition is divided into three types. It is a digitally operating electronic apparatus. It is just like your controller. Okay, so what controller uses? It uses all programmable memory and all CPU kind of hardware, uh, and this hardware uh, is what which functions which this hardware is implementing. It implements specific function like logic, sequencing, timing, counting, arithmetic calculation, etc, etc. Okay, so it is a kind of controller. Okay, but that is we can say it is specially designed for the industrial purpose. Okay, so controller is designed for industrial purpose, which replace old relay logic, which we have seen in previous slide. It consists of input output section, control section, memory section, power supply, and the software. Okay, so these are the components of the PLC. PLC has a modular nature, which we can increase number of input output in the PLC. So that's why it is having a modular nature. It has advanced functions like timer, counter, and other specialized modules are also there, like thermocouple module, RTD module, relay module, etc. It is aimed to work in the harsh environment condition which are observed in the industry. So which are the harsh environmental condition, like extreme temperature in steel industry, or extreme humid environment, where it is not possible for all human to go there physically and work physically. Okay, and which are the manufacturers of this PLC? Some of manufacturers are Allen Bradley, Siemens, Fanuc, Messung, Mitsubishi, Modicon, LG, and there are thousands of manufacturers of the PLC. Next thing, what is the difference between PC and the PLC? You might have seen the PC. So it is a very bulky, and it is very hard to carry this PC to some other place. Okay, so this computer is optimized for calculation and displaying the task. It is more user focused and the user friendly, and it is not meant for the real time applications. Okay, so in the real time application, what we have to do, we have to send some parameter and process it. Okay, so in the extreme harsh conditions, it is not possible to operate a PC in the industrial environment. Okay, on other side, PLC is a process oriented or the task oriented. Whatever task we have assigned, it will perform it independently. Okay, PLC is designed for the logic control and the regulation of the task. It has to operate in the real time. Okay, so PC we cannot use in real time, we can use this in real time, and we can may not use PC in the industrial environment. PLC can be used in the industrial environment. Okay, so that's why we are not using PC, we are not using a general purpose controller, but we are using PLC, which is specifically designed for the industrial environment. Okay, so we will see the block diagram of the PLC. Okay, so this is just one example schematic of the PLC. So as you can see, these are the inputs. So PLC relays are connected to these input cards, and uh, output, those are we cannot see these outputs as the picture is not uh, means uh, means we cannot see the outputs over here, but like this there is an interface for the outputs. Okay, this is the PLC power supply, and these inputs and outputs are connected to these LEDs. So whenever input will arrive, this LED will glow. Okay, and these inputs are given to this CPU. It will process the inputs and it will give output to the your output card. Okay, and this is the interface for the communication. We can connect PC to this PLC. Programs are normally done in the PC and those are transferred to this PLC via this port, or we can connect this PLC in the network. Okay, so this is the general schematic of the PLC. It consists of three main blocks: input module. So input module get the inputs from the sensors. Sensors will convert physical parameter into electrical parameter. So which are the sensors? Push button, contact, or limit switch, or any kind of sensors we can use. So this electrical signal is given to input module, and uh, it will be stored in the input output memory of the PLC. Okay, so whenever input is arrived, and the status of input output memory will be read by the this processor section. Okay, so it consists of some logic solver, memory module. There are various memories are there, RAM, ROM, EEPROM, those memories are here. So a program uh, downloaded to PLC is stored in this ROM, while for executing program RAM is used. Okay, logic solver. So this is the CPU of the CPU in the processor section, which is the heart of PLC, and it will do certain tasks assigned by the user, and after calculating the inputs, the outputs are given to the output module. Okay, so output module will convert electrical signal into physical signal, which is given to control valves, solenoid valves, motor, fan, or any kind of actuator. Okay, so first block is input output module, second block is the processor section, and third block is the program loader section. So by using your handheld device or by using PC, you can download this program to the CPU. Okay, so this is the program loader or communication base section. So you can connect a monitor or PC or handheld device by these ports. Okay, and there is a power supply, so it gives power to the all PLC. So this is the general explanation of the block diagram of the PLC. Now, which are the advantages of PLC? So it require a reduced space, energy can be saved, maintenance of the PLC is very easy, it is economical, it saves hardware and the wiring cost. Only the initial investment is required, but the bulkiness and expensiveness and all other kind of other hardware and wiring cost is saved. Okay, so we are in benefit if we will use the PLC. So it is a economical, it is a versatile, it means we can apply analog as well as digital signals to the PLC. Okay, it has greater life and the reliability, multiple functions can be performed at the same time. It is just like a PC which we are using in the industrial in general purpose activities. Okay, it has short project time, in very less time you can program the PLC for various application. Okay, so manual thing you will require more time. Okay, it is easier, uh, quick archiving and the documentation, then we can expand it very easily. It has more reliability, it has a wide scope for upgradation. Okay, so it means if we have purchased a PLC with 4 input 4 output, and if my business is growing, so I thought to expand my business, but it will require a 8 input and 8 output. Okay, so in this case I have to change the PLC. Okay, so this is one case. But if while purchasing the PLC, if I have purchased a PLC with whose CPU is of higher configuration, okay, so we can add 4 more inputs to the previous 4 and 4 more outputs to the previous one. Okay, so we can upgrade this PLC, we can convert 4 input output to the 8 input output. Okay, so just we have to uh, purchase the PLC with CPU of higher configuration. Okay, so upgradation is very easy in the PLC. There is a relay protection of the input output. Okay, it is well suited with stand in the industrial environment, which is not possible in the by using PC or the microcontroller, and it has simplicity of the operation. Okay, so there are many advantages of PLC. That's why these PLCs are generally used in the industrial environment. So same as your disadvantages, advantages, there are some disadvantages of PLC as well. So it is not suitable for small or simple functions. Okay, so it will be very costly if you will use a single uh, PLC for the single application or the lesser application. Okay, so for if we have a very huge business at that time only, it is suitable for us to use the PLC. Next, there is a too much work required in connecting wires. So this is just the connections we have to do in the PLC. There is a difficulty with changes or the replacement. So if I have taught you, this has a scope for the upgradation, but while purchasing the PLC, if I have purchased a PLC of the fixed configuration, then we cannot change or replace uh, the input output or upgrade the PLC. Okay, so there is a difficulty in the changing these input output, so in this case you have to replace the PLC. So the solution for this is that you should purchase a modular PLC. Okay, there is a difficulty in finding errors, so not all person can detect where errors are occurring, so a very skillful workforce is required to operate the PLC. So it is costly for smaller application, I have told this it in the first point. At the time of power failure, PLC does not turn on automatically after restoring the electricity. Okay, so there is should be some alternate arrangement in case of the time of the power failure. This PLC is useful in only yes or no kind of the decisions. Okay, and it is less flexible in comparison with the microprocessors. So these are some disadvantages of the PLC. Now we will see some applications of the PLC where PLCs are used in car parking system, traffic light control system, soft drink dispensers, reaction vessels, uh, NC or CNC machine, tank level control, doorbell digital lock system, microwave oven, bottling plant, switching off lights, mixing of two chemicals, starter control, over broadband and VoIP services, in automation for painting industry, high speed elevators, in space technology, in satellite launching, everywhere you can see the PLC. Okay, so these are only few areas or few applications of the PLC. So this is the setup of PLC which we are having in our lab. So this is the Allen Bradley PLC. These are input, output, processor, and power supply is there, and it is interfaced with this manual things. From here you can give inputs to the PLC. These are the digital inputs. This is the analog input. This is analog output. Uh, this is the digital output, and there are some add-on modules are there. Okay, so we are going to see this setup whenever we will visit our laboratory. Next point is the classification of PLC. So as I have told you, there are two type of PLCs. This is a fixed PLC, or it is also called as unitary PLC, or it is also called as micro PLC, shoebox PLC, or the monolithic PLC. Okay, so the configuration of this PLC is fixed. Number of inputs are always fixed, number of outputs are always fixed. We cannot expand this PLC if we want to expand our business. Okay, so it has a fixed nature. Okay, so as this is having a fixed IOs and the fixed power supply, CPU is also of the fixed capacity. So where we are using this unitary or monolithic or fixed PLC, it is used in the small scale industries where we have to do only small works. Okay, so as complexity of this PLC is less, it has a very less cost. Okay, an example of this PLC is a Micrologix 1000 PLC by the Allen Bradley company. Okay, and there is another type of the PLC which is the modular PLC, which we can expand as per our requirement. Okay, so in this again there are certain types: small size PLC, medium size PLC, large cell PLC, nano PLC, etc. Okay, so in this modular PLC, the processor is fixed and it is of the higher configuration. Okay, so whenever we will require any kind of uh, expansion, in this case we can add the inputs in. So these are the racks just right to the CPU of the PLC, and in these racks you can mount these input cards or output cards. Okay, so by adding these cards you can expand this PLC or input outputs of the PLC. Okay, so these cards can be digital input card or analog input card, or digital output card or analog output card. Okay, so we can expand this part, so that's why it is called as a modular PLC, and there is a power supply as well. So we can remove these cards or we can add these cards as per the requirement. Okay, so this is just the representation. So this is the cabinet in which we have to insert or we have to remove this card. Okay, so The classification of this PLC, modular PLC, can be categorized as nano PLC, micro PLC, small PLC, medium PLC, large PLC, and very large PLC. Okay, so this nano PLC, if the IO count of PLC is up to 16, then we say this PLC as a nano PLC. If the IO count is up to 32 IOs, then we call it as a micro PLC. If the IO count is up to 128, then we call that PLC as a small PLC, small size PLC. Okay, so this kind of small PLC has memory up to 2 KB to 10 kilobytes. Next is the medium PLC. They have additional functions like arithmetic and mathematical operations and few functions, or the PID, process control, etc. Okay, so the IO capacity of this PLC is from 128 to 2048, and the memory of these PLC is up to 32 kilobyte. Then large PLC. These PLCs are designed for the large scale industry for complete factory automation. Okay, the major disadvantage of this PLC is total production will stop if PLC will stop function. Okay, so IO count of these PLC is up to 4098 input outputs, and the memory is up to 750 kilobyte. Okay, so memory is it is a memory require in which the PLC program is stored. Okay, and there is a very large PLC from 4098 up to 8192 IOs are there in the very large PLCs. Okay, so based on the size, PLCs are classified in these types: nano PLC, micro PLC, small PLC, medium PLC, large PLC, and very large PLC.